Hi everyone, and welcome to today's flipped instructional session over 1.07 data collection. Be sure to take notes during this recording. You want to be sure to have all the key terms defined and make sure that you're adding in anything, figures or charts that might be helpful as well. Be sure to title your note page with the lesson number and title. So this one should be titled 1.07, and let's jump into the lesson. So we're talking about data collection today. So as you're working through an experiment, data can include measurements such as temperature of a mixture or observations such as the color of a substance. Data are pieces of information collected while doing the experiment part of the investigation. So that is a key term you probably want to find. What are some other examples of data that could be collected about the objects in the simulation? So if we're looking at the objects, we see a green square, we see an orange ball, we see that the square weighs 10 grams. So things you could collect would be the shape, the color, the mass, and the height. So we're able to see that this ball is about 20 centimeters tall. So our goal today is to design a data collection table. You'll need to do that in your lab coming up. And we want to measure, record, calculate, and report results using metric units. We want to explain how to collect data during a scientific investigation, identify possible sources of error in the experiment and in the data collected, arrange scientific data using charts, tables, graphs, visuals, or written descriptions, and then describe the difference between quantitative and qualitative data. So again, if you access the student guide, it's the same each time, that Word document that gives you a template. So we are ready to move on to the lesson content. So we have lots of things going on here. First, data are used as evidence. Scientists collect data to determine whether the information coming from their experiment support their hypotheses. Think of data as evidence. Data collected during the experiment are used as evidence to support or refute a hypothesis. So data fall into one or two categories: qualitative or quantitative. Qualitative data describes qualities. So this is something you want to put in your notes. Words, codes, drawings, or symbols, they can be qualitative. So sometimes you have to observe the nature of an object before you can make decisions about what you're observing. Data such as observations are known as qualitative data. Qualitative data measure the quality of something, such as its color or shape. Qualitative data are often expressed as word descriptions of things. So color, cloudiness, presence of water, straightness of a path. So you may want a definition of qualitative as well as some examples. Quantitative data measures quantities. So you can pull that word out of quantitative. So that's data recorded as counts or measurement. So that's an easy definition for you. And quantitative data measure the quantity of something using numbers. An example of quantitative data would be the temperature of a liquid measured in degrees Celsius. Scientists often use quantitative data using measuring tools such as a ruler, a graduated cylinder, a scale, or a stopwatch. Always use the metric system and measure quantitative data in units appropriate to the experiment. The mass of small objects, such as a golf ball, should be measured in grams, not kilograms. Kilograms would be more appropriate for measuring something heavier, such as the mass of a bowling ball. Take a look at these measuring tools. So which one would you use to measure temperature changes? Pretty easy. That would be a thermometer. With which one would you measure how long it takes a toy car to go down a ramp? So looking above, a stopwatch is a good fit. And finally, which one could measure the amount of rainfall? If you look above, pretty easy, the graduated cylinder. So when you create a data table, it's very important to make it very easy to read. So you have to think through it before you start putting in numbers. Once you know what kind of data table to look for in an experiment, you'll need to have an organized and functional way of recording it. So this is where your data table comes in. By using a table, you can easily analyze the information later. So labeling your data table. A data table should always include a title and column labels. So think about someone else reading your data table. For you, it's very easy. You may not need all the labels, but when you're sharing your information with someone else, they need to know exactly what they're looking at. So a title and then labeling each of your columns. So take a look at this example. The units are not written next to each number. Instead, they're written at the top of each column, and that makes it easier to read the data table. So we know everything in this category here in this column is in centimeters, and this is time. We know this is in seconds. So see if you can read the data table to find the answer to these questions. What distances were used in the time trials? So you have trial 1, trial 2, trial 3, and you have distance. So very easy, you can see 10, 20, and 30 centimeters. How long did it take the car to travel 10 centimeters in trial 2? So we look at the 10, go over to the 2, and we're easily able to see 2.10 seconds. Finally, how long did it take the car to travel 30 centimeters in trial 3? So 30, trial 3, 6.03 seconds. Errors in measurement. So this can easily happen. If you conduct repeated trials, you'll end up with slightly different measurements. No matter how careful you are, you might hold a ruler differently or start the timer too early. Sometimes you might notice a measurement that is much different from the others. If that happens, it's a good idea to repeat that measurement. If your new value is more consistent with the other results, you can keep that one and remove the one measurement from your results. So you would remove the one that's way off. You should only do this when the measurement is much different from the rest of your data, indicating something went wrong with that measurement. So take a look at the example of the data collected for a toy car. So you have 10 centimeters and you see 2.2 seconds, 15.03 seconds, and 1.95 seconds. So are their results consistent? We see no, they are not. This number is very much different. So what should the student do? Repeat that trial again, collect a new time, and replace the 15.03. Let me go back. I want to make sure that we did not get everything on that page. So when you calculate an average, you've got to summarize the results of multiple trials, and you will have to calculate an average or a mean. An average simply means adding up all the numbers to get one number that represents the most. So by finding an average, you can end up with a more accurate number than any single value. So here's how you find your average. You are going to add the values from each trial. So here we're looking at all the numbers that went 10 centimeters. So trial 1, 2, and 3, add those up. Divide them by 3 because there are 3 trials, and our average time is 2.2 seconds. And then you just keep doing that for the second one. Add up these 3 numbers, divide by 3, you get an average of 4.07. And here you can do the same and get 6. All right, so next, using a data table. You're going to practice using a data table with data that you will collect with a simulation. So record this data table in your notes and fill it in as you complete the experiment. So this is very helpful because you will be doing something like this in your lab coming up. So you've got 3 types of balls and you're going to drop them from a specific height. It shows 70 centimeters and you're going to measure how high the ball bounces. So this is something that you could do. It's in a simulation, so you do not need to go find all of these different types of balls. Again, I'm going to make sure that we got everything. Okay, scrolling down. All right, so now here is that simulation. You're looking at collecting the data here. So you pick up one of the balls and make sure that the bottom of the ball aligns with the 70 centimeter mark. So if we pick up the ball of clay, the bottom of the ball is at the 70 centimeter mark. Release it. And then we're going to measure the height of its first bounce. And you measure from the bottom of the ball. It didn't bounce at all. So your number here would be 0. So you repeat that 3 times and record it on your data table. So you can do that if you're going through the lesson. If we lift it up again, it doesn't bounce. So all 3 trials, you should get 0. Okay, this is the ping pong ball. Oh, we have to move this clay out of the way. Ping pong ball, so 70. It's kind of hard to tell because it goes really fast. So you're wanting to measure the bottom of the ball with the first bounce. So it looks to me like it goes to about 20. Now I can't find the tennis ball. I'll have to reset it. Or the ping pong ball. So hopefully you're able to see that. Okay, the tennis ball, and you're filling in the data there. Looks like it bounces to 40. We can see the 8 ball. It does bounce a little bit. It looks like it's maybe 10. It's a little hard to see. I'll move this up. So maybe 10 centimeters. Tennis ball again. Looks like 40. It's not going to be a very precise number. Maybe it's higher than 40, so you can write those down. And then what are some of the reasons that our measurements are not identical? So if you saw me trying to do this, we have balls bouncing everywhere. And we're able to see that sometimes the ball may be a tiny bit higher, lower. That could be a factor. So the ruler can be used to measure the diameter or the height of the balls when dropped. So, and then how do you calculate? Remember, you add up those numbers and divide it by how many trials you did. All right, so for this example, this is what your chart would look like filled in, but you're able to take a look and see what's wrong with it. So if we take a look at the data table that was created by a student who conducted the experiment to test the maximum bounce height, what is wrong with the data table? So we see trial 1, the clay ball 0, 8 ball 25, tennis ball 50, golf ball 63. That seems pretty normal. These numbers look pretty normal. Okay, when we get up here, this 85 looks off. We didn't see anything really go that high at all. And then you have this other one that's 59, which seems a lot lower than these two. So a couple of things here. We don't have a title on the data table. We also don't have the unit of measurement. So let's see. We have the missing title. It's missing a column. With the label in the first column, it should say type of ball. We don't have a title up here to say label it. The column is missing for trial 1, trial 2. It doesn't describe the data collected. So we are not knowing if this is, millimeters, how tall, how inches, anything. We use the metric system, but we don't know how this person measured. Error 4, it looks like the third trial for the tennis ball should have been repeated because look at this number 85, it seems very different. And then the student should have included a column with the average values. So remember the average that we did on the last one. So a couple of things to keep in mind there. All right, that looks like we are at the end of the lesson. So with that, you are getting ready to go into your drop and bounce, your first virtual lab. So as we wrap this one up, your next steps will be to look for our flip follow-up session in the week and attend Help Lab sessions if you have questions. We will see you guys next time.